So let me go over 4.1 today. If there is time permits, we could go for 4.2. But I'm focusing on 4.1 today. Um, okay, so let's look at the definition of antiderivative. Okay, so the antiderivative is kind of doing backwards of derivatives. Okay, so suppose you know if you are given right a function, say if you are given a function fx, okay, this is given, and if you are asked to find what is the antiderivative of fx, okay, so antiderivative of little fx, suppose say my answer is another function, say big fx, okay, what does mean by that? That means if you differentiate the answer, the antiderivative of little f, that should give back you the original function you are given at the beginning. Okay, in another word, if big fx is antiderivative of little f, that means if you take the derivative of big f should be equals to little f. Understand? So in another word, if you are asked to find the antiderivative of given function, you have to ask yourself, right, which function derivative will give you that given function. That is called the antiderivative, right? Look at this. Just a minute. Now look at these given examples. This says x cubed over 3 is an antiderivative of x squared. What does mean by that? That means if you find the derivative of f prime, that should give you little f. Is that true? Let us check. The derivative of the given f is now big F is x cubed over 3. What is the derivative of that? The derivative of this guy is 1/3. Exponential power says 3 times x, 3 minus 1. 3 gone. That is simply x squared. What does mean by that? That means the antiderivative of x squared is nothing but x cubed over 3. That's what this says, right? Do you understand?
Yes.
Yes. So you had to go backwards. Okay. So if you are asked to find the antiderivative, you have to, check your answer by differentiating. If you differentiate your answer, that should give you the original given problem. Okay. Now look at this one. The antiderivative is now sine x of which function? Of cosine x. What does mean by that? That means if you take the derivative of antiderivative sine x, the derivative of sine is cosine. Okay. Therefore, sine x is the antiderivative function of cosine x. Okay, so this is another example. So if you take the derivative of this function, that will give you sine pi x. Therefore, this guy is antiderivative of sine pi x. Okay, so that's the definition of antiderivative, right? So now this is the little theorem we have. Suppose if f is an antiderivative of little f, right? Then another function gx, that is simply the original antiderivative function, and you are adding some constant. Okay, this also going to be, you know is also going to be a possible antiderivative function of little f. Okay, this is also, okay, this is also an antiderivative of little f. Okay, that means what? That means after finding the antiderivative, you are free to choose any constant here. For example, look at this problem. Okay, mm, I'm asking you one question. Okay, let's see whether you understood. Could you tell me what is the antiderivative of 2x? Could you think of this? Your given function is 2x. The question is, what is the antiderivative of 2x? What does mean by that? That means you need to find out one function fx. You have to tell me now, right? whose derivative should give back 2x. Which
X
functions?
squared.
X squared. Very good. So your fx would be x squared, right? So if you take the derivative x squared, you should get 2x. So this is an antiderivative of 2x, obviously. But now I am free to choose any constant here. Say my constant is here, I am adding 5, right? Do you think that this answer also going to be an antiderivative of 2x?
No.
I should say yes. You see the definition. What is the derivative of this guy? What is f prime x here? Just
2x.
find 2x, right?
2x.
Why this? Because the constant derivative is 0. Isn't that? So that means if you take the derivative of x squared plus any constant, that should will give you always 2x. That is the given function here. That makes sense? Therefore, the antiderivative of 2x will be x squared plus any constant. You are free to choose any constant. Instead of 5, you could choose any constant. So once you take the derivative of that answer, you should get back to x. Okay, that's what this theorem says. So if you are asked to find the antiderivative of little f, you could, find big fx, and you are free to choose, any constant here. Okay, so that is here explained. So now let's move to the another concept. This is about the differential equation. Like ordinary, linear equation, we have differential equation as well. What does mean by differential equation? You will have an equation, right, in terms of what? Derivatives and variables. Okay. Here y prime is a derivative of y with respect to x. So y prime is nothing but dy over dx. So if you see an equation with y prime, that is called the differential equation, right? Not only y prime, you may have any derivatives here, but the simple differential equation is we have here is y prime. Look at this. So this is one example of a differential equation, right? You see y prime, and you have some functions here. Here you may have constant as well. Constant also a function, right? So you may have like this also 3y prime is equal say 5. So this is also a differential equation. Whenever you see y prime, that is going to be differential equation. Okay. You could have any number here. Even this also possible. Y prime is 0. Also a differential equation. Okay. So now you are given this differential equation, right? Find the general solution of the differential equation, like the solution of, like a solution of linear equation. Suppose if you want to find the solution of this equation, could you tell me what is that? If you are asked to find the solution of this equation, simply you are asked to find x value, am I right? In similar
Yes.
way, if you want to find the solution of differential equation, what does mean by that? That means they are asking you to find the y. Okay. Now, question is clear. You are asked to find y, right? In words, what are they asking? They are asking, hey, could you find y value such that the derivative of that y with respect to x giving 2? What are they asking? In another word, they are asking you to find antiderivative of 2. That is the meaning, right? So what is the antiderivative of 2? 2x, right?
Yes.
Therefore, the possible solution of y is here 2x. That makes sense. So always we had to solve for y. That's the meaning of solving a differential equation, right? So that means what? That means once you have the derivative of that answer, dy over dx should give you 2, yes, 2x. But remember, as I said earlier, you are free to choose any constant here. So if you write here any constant, this c is, any fixed number. You could pick any number here. So this is called a general solution. That means what? That means I have included all possible antiderivative of 2. Once you change your c value, you will have different y values, right? So you have more than one answer for y once you change this c. So in this case, we say that, right? If you write here c in general, which is called the general solution. Okay, you see here. So if you want to find general solution, remember you need to add a constant after getting your antiderivative answer. Okay. Now look at this. Now for this particular problem, my answer is now y is equals to x plus c, right? Remember, now this is my solution y, but if you try to, plot the curve for this given relationship, this is nothing but linear relationship, right? Y is equal to x. So this is simply y is equal to x line plus some constant, right? Once you change this constant, you will have different lines, right? If you see 0, then what is my line here? If c is 0, your line is simply y is to x. So that is the line you have here. When c is 0, you have simply y is to x. When c is 2, when c is 2, you will get 2x plus 2. So this is another straight line, right? So that is this straight line. If c is negative 1, you have another straight line. You see now, all three scenarios are different now. All three lines are now different lines, right? But only thing is you could see here is slope of these three lines are now same, right? 2, 2, 2. So that is why all three lines are parallel lines. So you know that, right? For parallel lines, the slope should be same. Okay, so these are all possible answers for the antiderivative of a given differential equation or the solution of differential equation, right? So if you consider only one guy at a time, this one is called the particular solution of the differential equation. Particular solution means what? You are considering only some particular value for c. In this case, c is 0. This is another particular solution of the given differential equation. This is another. So there are three particular solutions, but altogether, if you write like this, which is called a general solution of differential equation. Most of the case, they will ask you to find the general solution. Okay, we don't know c, so you are simply write here c. C could be any arbitrary constant. Okay, right. So let's look at this, right? Suppose if you want to solve this differential equation, we don't know f is any function. So I'm writing here fx. So if you want to solve this differential equation, what does mean by that? That means you need to find y answer, right? Right. Remember I told you earlier here, how did you find this y answer? Simply you found the antiderivative of 2, right? Whatever you have the function here, you have to take the antiderivative of that function. That will give you the answer. In similar way, if you want to find y for this, differential equation, y is nothing but what? The antiderivative of this function fx. Now we are going to introduce one notation for this all. The antiderivative of any function fx is denoted by this notation. Okay, so the antiderivative of fx is simply this notation fx dx. This dx is called differentials. Now remember, you have to plug in the given original function here. Then once you see this notation, always you have to have this differential, like derivative operation. Go back and check your derivative problem. So what is the derivative of x squared? We will write like this, right? Now this notation is called what? The derivative operator, right? Because this guy will operate the function and taking the derivative, right? In similar way, this notation altogether, these two, like this. So you have to put some function here, right? This notation is called antiderivative notation, but we call that as integral. Okay, integral operator, if you want, you could say integral operator. Okay, so this is called the derivative operator. This is called the antiderivative operator or integral operator. Okay, So here you are free to choose any function to find the derivative with respect to x. Like that, here you are free to choose any function to find the integration with respect to x. This is the variable you have to have. Okay, right? Now it is clear. If you are asked to find the antiderivative of 2x, that is simply they are asking you to find this. Okay, so the explanation of this is what? The antiderivative of 2x. That is the meaning of this expression. You understand? So hereafter, if you see this symbol, we call that as the integral operation. Okay, you're finding the antiderivative. So everything is explained here, right? So this is the variable. If you have variable t in your problem, you have to replace here dt. Now in this default, we take x as the variable. So I'm writing dx. This is called integrand. This is the function you will be given at the beginning. So we are finding the antiderivative of this function, which is denoted by this notation. So normally we write that answer, antiderivative answer as y. Okay. So that is given by, this is my antiderivative of fx. Then you are adding some constant after finding the antiderivative. So this is going to be our general solution. Okay. Make sense?
Yes.
Yes. What about Sharon? Are you okay?
Yes, sir.
Okay. Good. Now we are into second, larger things into calculus. Finding antiderivatives, integration, we call that as. Okay. Again, like derivatives, here also you will have bunch of formulas. Finding the antiderivative of, so many basic functions, right? Okay. Now, basic integration rule. So don't forget, hereafter we are going to use this term integration instead of antiderivative. Same meaning, okay? Do you understand this? The antiderivative of f prime x is always f. That makes sense, right? Because if this is your antiderivative, once you take the derivative of this, it should give back the answer inside function fx, little fx. Now this is my little fx, okay? So simply I'm using with its derivative. So this is the basic operation rule we had here, right? We know now, right? So the antiderivative of little f, if this is big F, that means what? This says what? This says if you take the derivative of f prime, you should give back the original function, right? So now what are they doing? Instead of that f function, we could write f prime here. Remember the earlier notation we had like this, right? The antiderivative of the original function is big fx plus c. But now you know instead of this guy, you could replace by f prime. That is why you have here f prime. So this is basic integration rule. Okay. The second one says what? Yes, if you take the derivative of antiderivative answer, it should give back the original function. Makes sense, right?
Yes.
Yes. Okay, now these are the basic formula like derivative you have to, you see now, the first column says about the derivative, right? The second column is about the integration, right? What does mean by that? If you go backwards, you should get the derivative answer. Okay. They are telling that the antiderivative of zero function is always constant function. What does mean by that? If you take the derivative of constant, it should give you zero. Yes, that's correct. The antiderivative of constant function k is always that constant times the variable. If you have variable here x, replace x. If you have variable y, replace y. Okay. For instance, suppose if you want to find the derivative of this, what is this? Now the variable is t here, so that is constant times t plus another constant like this. Okay, so here you are free to choose any variable. This variable x based on your integral operator variable. Okay, now the third rule says what? If you multiply constant with any function, like a differentiation, you could pull the constant in front of the integral sign. Okay, like a differentiation. Always it is better to compare with the the derivative properties you learned with the integration. So it will be always easy to memorize. Okay, remember for the derivative operator, right? If you are given two functions between plus or minus sign, you are free to distribute this operator for each function, right? The same thing here also can be done. If you want to find the plus or minus with the function integration, you are free to find the integration separately, one by one. Okay. So you could distribute this integral sign to both. That is the meaning. Remember here for the derivative, now after studying integration, you should not be confused. The derivative of x to the n is n times x n minus 1, whereas the integration of x to the n is you have to add and divide. Here, subtract, multiplying, but here adding 1 and dividing by that n plus 1 here. Okay, so remember this. If you want to apply this formula, your n should not be equals to -1. Okay, your n cannot be -1 here. That means what? This formula will not be valid if x is -1. That means you cannot find
0 in the denominator.
exactly. So you cannot find this guy. Okay, so you cannot apply. You cannot apply this formula for here because n is -1. Other than that, this equation is fine. Okay, so the antiderivative of cosine x is sine x. Yes, if you take the derivative of sine, it will be cosine. Right? So the antiderivative of sine is negative cosine. Here we go. No confusion, okay? Why it is? Because if you take the derivative of this, it should give you sine x. Yes, correct. Because the derivative of cosine is negative sine. Here you have already another negative, so it will make positive sign. Okay? So the antiderivative of secant squared is tangent x. The derivative of tangent is secant squared. Backwards. Again, the antiderivative of secant tangent is secant. The antiderivative of cosecant squared is negative cotangent x. The antiderivative of cosecant x times cotangent x is simply negative cosecant x. Okay. Since you have this formula sheet, so try to memorize these things. You should not be any confusion with with these formulas. You should be good. Okay. Right. Now use these properties. Use these properties and find out the given problem. This is very obvious. You are asked to find the antiderivative of 3x. 3 is constant. You could pull out. Now the question is x dx. Now remember power is 1. So you could use the power rule for the integration. So x to the n is x to the n plus 1 over n plus 1 plus constant. So now n is 1 in this problem. So simply plug in 1 here and you will get answer, right? So simplify this guy. So the antiderivative of 3x is 3x squared over 2. You could check your answer is correct or wrong. If you take the derivative of your answer, it should give you 3x. Should give you 3x. Okay, that is what they are telling here. Okay. Now these are very good, problems to observe. Okay. So the first one, if you are given like this problem, try to write down by using exponents property. 1 over x3 is x to the -3. After that, apply that, the power rule for the integration. So you will get that, right? After that, simplify like this. Again, second one, square root x means x to the power half. Yes, I'm good to use that formula. So answer is this. Now here, 2 is constant multiple, right? Pull outside of integration sign. What is that antiderivative sign? Yes, we know that. That is negative cosine x, right? Antiderivative sign is negative cosine. Then after finding the integration answer, always you have to put the constant here. Arbitrary constant. Don't forget to put this constant, okay? Okay, very good. Oh, you see now, what is the antiderivative of dx? You don't find anything here. If it is blank, that means you have to assume one is there always. Okay. One is also a function, which is a constant function, right? So one is now here a constant. So you could think of k. So you could go for the constant function derivative. The constant function derivative is k, the constant times x. Now in this problem, our constant is 1. So answer should be 1 times x plus constant. That is simply x plus c. That is why you have that answer here. Okay. Make sure that you understand all the steps. Here, what are they doing? Here they are doing what? By splitting the integral sign separately to these two. You could think of these two like two functions. This is like f function. This is like g function. You have plus sign in between. Remember the formula? The integral of f plus g dx is simply f dx plus g dx. I have to tell one thing, whenever you write this symbol for the integration, you have to write always this differential operator, okay? Otherwise, it doesn't make any sense. Okay, so make sure that you put that. Now, in this problem, our f function is x and our g function is 2. So this is simply x dx plus 2 dx. Okay, that is why you have this step here. Make sure that you understand. After splitting into two integrals, now you are going to use those properties. Okay, so the first integral is the integration of x. Now you know the integration of x. Power is 1, so x to the over 2. Okay, plus some constant. Now the second integral is what? The integral of constant is constant times the variable x. So now you are putting another constant. Okay, remember these two are constant values. So I could add these two, right? After adding these two, you could label that new constant as another constant c. It is possible, right? So I'm relabeling, I'm renaming these two constant as a new constant c. So this is my final answer. If you have more than one constant in your, final step, you could combine all the constant and you could relabel that as a one constant, right? When you type your answer into a design like these problems, make sure that you combine into one, constant. Otherwise, it will show you always wrong answer. Okay. Are you following me so far?
Yes, sir.
Yes.
Yeah.
So I believe remaining all, it is explained clearly here. So you could go through, okay, all the problem. That is there. So on this particular, application of integration, this is the real life problem we use. Look at that example 8. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Assume that acceleration is given by acceleration is a function with time t, which is now constant function, negative 32. Okay, so you are given acceleration function. Find the position function giving the height s as a function of the time t. Okay, so what are they telling? They are asking us to find, a position function s that is also a function in t, time. When time varies, of course, our position of the object also going to be varied, right? Therefore, st is the function of t. But what is the given condition? The given condition was the acceleration function, right? The acceleration function is negative 32. So this is position function. Now let's see who is telling. What is the connection we have between um, position function and acceleration function? What is the connection between these two functions?
Well, one's the first derivative and the other is the second derivative.
Oh, you see now, if we take the derivative of the position function, we write that as s prime. Okay, the derivative of position function is should be velocity function, right? If you take one more derivative of the velocity function, that is s double prime, which is called the acceleration function. Acceleration function. Okay, so this is s double prime is basically going to be acceleration function at. So this is the relationship we have. Okay, s double prime t is always at. What does mean by this notation? This means you are taking two derivatives consecutively to what? To s function, right? So this is the meaning. Okay. Now what is the question? Question is you are given at now. You know at, right? It is given in the problem, negative 32. The question is finding s, position function, based on this, right? Okay, now I'm going backwards. You know at function, right? What is the relationship between at and the position? Yes, this is the relationship. Do you see that? Okay, so look at here. If my position function is st, then what does mean by this notation? This notation says that the position evaluated at the time 0, at the beginning. At the beginning, we know that the height of that particular object is 80. Therefore, when t is 0, the height, the position is 80. Okay. Remember I told you, if s is a position function, s prime is going to be velocity function, right? They are given velocity also. You see now the velocity of the ball at the beginning is 64. Therefore, s prime at 0 also known, which is 64. So basically, you know these two things, right? The question is now finding st. Okay, so this is the connection we have. Acceleration is given by the double derivative of the position. Okay, but if you take the antiderivative of s double prime, that means you are going backwards, so it will give you the first derivative, right? So that is the meaning of this, no? So the antiderivative of s double prime is always going to be s prime. Now we know s double prime is negative 32 because s double prime is acceleration, which is negative 32. So now simply you need to find the antiderivative of negative 32. We know that that is negative 32 is constant times t. Okay. Then we add one arbitrary constant, right? So this step says what? This step says s prime t is equals to this. But the good thing is we know s prime 0. S prime 0 is 64. What does mean by that? That means if you plug in t0 in this relationship, sorry, you find s prime 0, right? Simply plugging t0 here. So that means s prime 0 should give you, if you plug in here 0, you will get simply the constant c1, right? So, but that answer known 64 because you know s prime 0 is 64. That means you are free to find out now that c1, right? This is simple equation. 64 is equals, this is 0, c1. Therefore, c1 is 64. So we know that constant now. c1 should be 64, right? So you could go back and replace c1 by 64. Therefore, my velocity function is negative 32t plus 64. So I got, velocity function. But remember, my question is finding position function st. That means what? That means if you take one more time antiderivative of s prime, you will get s. That is what this says. Okay, the antiderivative of s prime is s, but now we know s prime. S prime is this guy. Simply plugging that one here. Now find the antiderivative of this function. So you know all the properties now. X split into 2. So find the derivative of 32t, t squared over 2, and simplify, which is negative 16. Then the constant derivative, antiderivative is that constant times the variable t plus another constant c2, right? So this is my position function answer. So my ST position function is negative 16t squared plus 64t and plus another arbitrary constant. Can I find this constant? Yes, we could find because you know another condition. S0 is 80. So if you plug in here 0, S0 should be 80. So plugging T0 here will give you S0. So if you plug in T0 here, this is 0, this is 0, simply you will get C2, right? But we know S0. What is S0? S0 is 80. Therefore, this is 80. So it should give you C2 as 80. Now you know C2 constant, plug in here and you will find the final answer, persistent function now. So my persistent function ST is now negative 16t squared plus 64t plus second arbitrary constant, which is now 80. So this is our answer for part A. Right? Now this is the relationship between the position of that ball at any time t and t time. Right? Very good problem this is. So that is first part. Now the second part is what? When does the ball hit the ground? That means what? That means they're asking, hey, how long it will take to hit the ground, that ball. How do you find that? Any idea? Okay, look at the picture. At the beginning, the height of the ball was 80, about 80, feet ball was thrown. It's going like this and hitting the ground. When ball hits the ground, the position should be 0, right? Because you measure the position from the ground level. So this is the ground level of the problem. This is the ground level, right? So ball at the beginning, it was 80 feet. But when you hit the ground, when that ball hits the ground, that S should be 0. Position should be 0. In such a way, you need to find a T. That is why they take the position function this when setting to 0. Then this is nothing but a quadratic equation. Now we know how to solve that using either factoring or b squared minus 4ac formula. So you are good to find the possible t values. So you got two t answers, right? Remember, t is the time taken of the object throughout the traveling. So you got two t answer. One is impossible, right? Because time cannot be negative. Therefore, the possible answer is 5 seconds. So because t must be positive, you can conclude that the ball hits the ground after 5 seconds of the throwing. Make sense?
Yes.
Yes, sir.
Yes, very good. You might have seen same problems in high school, right? When you study these things.
And only in physics, but we didn't think about it in that way.
Now it is clear, no? Now we are kind of mature, in terms of calculus. Okay, very good question. So this all about finding antiderivative, and you should have now, the notations and everything should be clear with you guys, and make sure that you understand everything. Okay. So I'm not going over 4.2 today, okay? But just I am giving some outline. Why don't you look at 4.2 and 4.3 during this week, and I will go through 4.2 and 4.3 on coming meeting, okay? But what's happening here? Now this is the catch. We are going to use that antiderivative integration techniques to find what? The area of any curve. You'll be given a curve, right? That means you will given a function of the curve, right? Now we need to figure out the area of that curve, under that given conditions, okay? Suppose, say, if you want to find the area of this curve fx from xa to b, how do you find this area? Now we are going to use the tool, calculus tool, to find the area of the curve, okay, under the given conditions, right? So how do you find this area? Well, I'm going to use what? The integrations, okay? So we are going to find out the relationship between area under the curve and the integral sign. To get that, we need to have a lot of, the tools. So that those are the things now you are going to learn in this section 4.2, finding area. This is the idea. So if you want to find, the area of the curve, say I want to find from A to B. This idea says what? You need to chop up the given interval. You are asked to find the area of this curve from A to B, right? What are we doing? We are going to chop up this interval into small pieces with equal length, like this. And we will perform like this, um, some blocks on those intervals. And we will approximate the area by looking at, you know, like these rectangles, okay? So we approximate the area by looking at the rectangles area. So basically we are going to divide the entire region into sub-rectangles intervals, and you find the area one by one, then adding up all the areas will give you approximate, answer of the area. Not exactly, it will give you some approximation. Okay, there are two types of approximation of this area. One is called the under approximation. That means our approximation is below the original area. The another one is overestimation, right? Should be above the original area. So in this section, we find those kind of areas. Okay. So for that reason, we introduce some notations here. So we use these notations to summing up all the numbers. We call these as sigma. This is uppercase sigma in Greek letter, right? So this is a Greek letter. So we use this notation, and after that, we use to find out the sum of these numbers in terms of that notation. We call summation notation. Okay, so that is called summation. So now you can go through and try to find out all the antiderivative problems, and you could look at this all, how we you see now the things I explained. So if you want to find the area of the curve, we basically divide the entire interval into small intervals with equal length. That is the key point, okay? The interval of this subinterval length is, subinterval lengths are equal throughout this given interval. You are chopping up into small intervals and finding the rectangles area, then adding them, summing them by using the summation notation, and you will approximate the area under the curve. Okay, let's see who is telling. What kind of area this is? Is this underestimation or overestimation?
Under.
Why it is underestimation? Yes, you are correct, because my approximation rectangles are always under the curve, right? So if you find the area of the rectangles, of course, you see there are some places we left out. So we did not find this all we left out, right? We only find the rectangles area. Therefore, my summing up all the rectangles areas are now going to be smaller than the actual area. So it is going to be underestimation. But if you look at the second picture, now remember, all the rectangles are above the curve. So this is called the overestimation. So now go through all the work, whatever we have here. And first of all, I just want you to watch the videos on web design for 4.2. Okay. So then after that, I will be able to explain, and you will get, better understanding next time.